Find an approximation of the area between the curve y equals sine x and the x-axis from x is 0 to x is pi using 12 centered rectangles. Now let's have a quick think about the graph. So from 0 to pi it's just going to look like that. We know the maximum is here at pi by 2. So 12 centered rectangles. So we have pi by 12, then 2 pi by 12, and so on across to 12 pi by 12, which is pi. That will give us our 12 rectangles. So we can see that the width of a rectangle is going to be pi by 12. Now if they're centered, the first one here is going to be at pi by 24. Then the next one will be that add pi by 12, because we're going a whole width to get to the next center. So that's going to be our x-ordinates, and then we know the widths of this, and we can work out the heights. So first things first, we need to make sure the calculator is in radian mode, which it is. Now let's go back to the spreadsheet. So my first ordinate is pi by 24. So we'll just do equals pi divided by 24. And then we know they're pi by 12 apart. So the next one is going to be equals that, add pi divided by 12. And then we want to fill that down from A2 to A12. And then over here, that's going to be equals, and actually we can just go to here, sine of that one. And of course these are in radians, which is why the calculator needs to be in radians. And then we'll fill that one from B1 all the way to B12. And that's all of those. And then the last column is going to be equals that multiplied by the width of each rectangle, which we discussed was pi by 12. And now all we need to do is fill that down. So we'll fill a range from C1 to C12. And then we want the sum of all that lot. So equals SUM, open bracket, C1 down to C12. And there we go, and that's 2.00572. So let's say that's 2.006. Okay, so let's look for the actual true value, which we know from earlier discussions is going to be an integral. So what I'm going to do is do the integral and that's going to go from 0 to pi. Now we haven't actually met this yet, and it's what's coming. is what we're leading to. But I'm just showing you here how to get this. So we're going to have sine x, and we're going to integrate that with respect to x, and the answer is 2. So our approximation was 2.006.